come for this. Yeah, now let's get into power. From where the power will come, what all power? From where the resistance, because power equal to I square R, the resistance of antenna. So here there's a transmitter, AM transmitter, and this is the antenna, which will radiate. So this antenna will have a resistance. I'll call that as R. So what is R in the picture I'm bringing? That will be the antenna resistance. So which all components? Carrier, lower sideband, upper sideband. So let's get into the mathematics here. How we represent, and all these are what happen? Peak values, no? Peak values are there. So what is, this is resistance of antenna. Okay, how to express AC power, because all these are alternating signals. So what is how to express AC power? So therefore first we'll do one thing. Power of a carrier. PC shall I write? There'll be sufficient carrier PC. What is the amplitude of carrier wave? AC by root 2 whole square by R. And this is equal to how much? AC square by 2R. So this is power of carrier wave. Then power of upper sideband or lower sideband, because both are having same amplitude. Then what is the amplitude of that signal? Mu AC by 2 by root 2 whole square by R. 8R it will come. Okay, there's the power of upper sideband and lower side. Both sidebands will have same power. Then what is the total power of AM wave? Shall we add up this? Total power of AM wave. Power of carrier, or the power of sidebands, we'll write it first. This is also going to help us. So this should be equal to how much? Mu AC square by 4R. So what is this? Total power of sideband. Don't write bands, band. The sum of power of upper sideband, lower sideband is called like a power of sideband here. And is equal to how much? Mu AC square by 4R. Or what you can, shall we call that as useful power? Shall I call it as useful power? Why useful power? Because the information which you are transmitted, or the song, total power of sideband, because I said no, that song. So tell me, like, what is important for you to listen? That song is what important, no? And what all the power contained in that song at frequency of song, that should be the useful power. So I'll call that power contained in the sideband is called as a useful power here. So let's go for the total power in amplitude modulated waves. That should be equal to how much? The sum of, okay, I'll write this, because AC square by 4R. So this in terms of mu square by this AC square by 4R. I'll separate it. No, AC square by 4R, what you can write it as? AC square by 4R. So can we adjust here? 212. This will be, so I'm going to express now power of sideband in terms of power of carrier, that one. So shall we adjust one? By 8 is needed, no? So mu PC square by 2. Square. Okay, I'm missing square term. Huh? Mu square. Okay. Look, come for this one. AC square by 2R. AC square by 2R, what you can write? Mu square by 2. Power of sideband, I just like this. Mu square by 2. So what is the power of sideband in terms of carrier? You can express PC by 2. AC square by 2R is what? This one. PC. Okay, now let's come for power of amplitude modulated wave. What all it is having? Power of carrier, power of upper sideband, power of lower sideband. So this can also be written as power of sideband. What is the power of carrier? As it is, power of sideband, mu square PC by 2. So PC you take outside, 1 plus mu square by 2. This is what power of amplitude modulated wave. Okay, let's talk about I think there's a one very good formula which you have to remember here. Efficiency of AM in transmission. The next discussion is the power of a amplitude modulated wave. Now we'll discuss the efficiency of AM transmission. Useful power by total power. Why efficiency I'm bringing? Let's go back here. Tell me, like, there's a total power, no? What all you transmit, you are going to transmit this much. Agree this? In that what pen, where is useful? The useful power is only here. So definitely the efficiency will come into picture. Means of this everything will be transmitted. Of this what happened? How much is useful? Only these two are useful. So therefore the efficiency I'm bringing it. Useful power by total power. Total power of AM wave. What is useful power? Power in the side bands. Power of sideband mu square PC by 2. Power of AM wave. Just a formula, son, nothing big. Already you know from AC, no? V square by R. Since VM we know, VRMS square by R should be the power, AC power. We don't know VRMS, but we have maximum peak value. So VRMS, we write VM by root 2. Instead of voltages, here I'm bringing something A, amplitude. So PC get cancelled. So finally, I'll end up the equation for efficiency as mu square 1 plus mu square by 2. Yeah, one more. So this will become mu square by 2 plus mu square. And what is the maximum possible efficiency? Can we take mu equal to 5? If you take mu equal to 5, what is the problem? To improve the efficiency, shall I go for higher value of mu? So if you make mu more than 1, so what is the problem? It will become distorted, no? Information will be lost. Distorted AM wave. Distorted means what happened? The information is lost here. So what is the preferred value of mu? Mu should be equal to 1. So what is the maximum possible efficiency? At mu equal to 1 or 100% modulation. The efficiency is maximum. So how much it is? 1 square by 1 by 3. In terms of efficiency, we have to put it to 100. This will be 33%. It's not efficient one, no? Means if you are spending 100 joules to transmit this AM signal, of which only 33% is what useful power at the receiving end. The remaining what happened is lost. Is lost means it is of no use. So this is a maximum possible efficiency. How to improve efficiency? What shall I do? No, you go for mu. Mu should not be greater than 1. Strictly I'm telling this one. Mu greater than problem. Mu sir, 0.5. You do one thing. Mu equal to 0.5 or depth of modulation 50%. 50% modulation. Then in that case, how much it will become? Efficiency, we check it. 0.5. So 1 by 2 whole square, 2 plus 1 by 2 whole square. 1 by 9. Still more very poor, no? The efficiency will be. Anybody value 9%? 11, huh? Okay, this one, yeah. So definitely you can't go for higher value of mu. The lower value poor efficiency, the maximum permitted mu is 1. So that there's a maximum possible efficiency. Okay, I agree this. So these are the basic ideas of this amplitude modulation that one. So I think still most of you, so like we didn't understood what actually your thought. What is